Okay, our first percent yield problem, number 18, or sorry, the second percent yield problem. In order to produce a carbon dioxide, a student put a sample of calcium carbonate in a flask and added hydrochloric acid using the following equation. CaCO3, calcium carbonate, plus 2HCl yields CO2 and H2O. Okay, producing CO2, calcium carbonate, and hydrochloric acid. You should know that this is your calcium carbonate, and you should know that this is your hydrochloric acid. Says the student finds a mass of CO2 generated to be 1.00 times 10 to the second grams. If the student began with 2.00 times 10 to the second grams of HCl and there was ample calcium carbonate left unreacted, what is the percent yield? All right, so what this means is that we're really only worried about the hydrochloric acid and the carbon dioxide, the CO2. So the first thing you have to know in percent yield problems is you're always given two numbers, and one of them is the product, and that's, in this case, the CO2, because it says it's generated. And also, if you look at your balanced equation here, it shows the CO2 is after the arrow. And your product is always your actual yield. So you need to know that. And then you're also given this number here, the 2.0 times 10 to the second grams of hydrochloric acid. You need to know that that is your reactant, and you use it to get the theoretical yield. Okay, which means we got to start our guess method. To calculate the theoretical yield, we start with our reactant, the 2.00 times 10 to the second grams of HCl. And we know that we're trying to figure out how much product we can make, how much carbon dioxide, because we're going to compare that back with the mass that we were given, the actual yield. So in order to go from grams of HCl into grams of carbon dioxide, we got to go from grams of HCl into moles of HCl into moles of CO2, and then into grams of CO2. So this is a three-step conversion, just like always. First one is going to be molar mass. 1 mole of HCl is equal to blank grams of HCl. So that's 1 times hydrogen sorry, 1 times hydrogen, so that's 1.008, and 1 times chlorine, that's 35 point, wow, having lots of problems with the stylus today, 35.453, and these are both 1, so we just need to add these together, and we get 36.461. We stick that in our blank, 36.461. Then we need to do our mole to mole ratio, and we use our our coefficients for that. So we're trying to go from hydrochloric acid into carbon dioxide. So we look up here, it's 2 moles of hydrochloric acid to 1 mole of carbon dioxide because there's nothing in front of the CO2. So blank moles of HCl equals blank moles of CO2. Always blank of the first substance, blank of the second substance. We know that this is a 2, we know that's a 1. And then we do molar mass of carbon dioxide. So remember, molar mass is always 1 mole of your substance equals blank grams of your substance. So that's 1 times carbon, 1 times 12.011 is 12.011. 2 oxygen, so I'm writing a 1 and it's 2. 2 times oxygen, 2 times 15.999 equals 31.998. My brain is getting ahead of my pen. So when we add 12.011 and 31.998, we get 44.009. Put that up in our blank. There's our 3 equivalent statements. So now our guess method. Okay, remember the top is just your mole map. You're trying to go from grams of hydrochloric acid into moles of hydrochloric acid, into moles of CO2, into grams of CO2. So we got to cancel our units out, which means we need grams of HCl on bottom, we need moles of HCl on bottom, and we need moles of CO2 on bottom. And that way our grams cancel with our grams, our moles of hydrochloric acid cancel with our moles of hydrochloric acid, and our moles of CO2 cancel with our moles of CO2. And then we're ready to substitute in our numbers and solve this. So we're given 2.00 times 10 to the second grams of HCl. And remember, molar mass is always 1 mole over our mass, which is 36.461 grams. And I'm sorry for the ugly handwriting there. That number is that number right there, 36.461. And then we go mole to mole ratio. Mole to mole ratio is this. So that means 1 mole of carbon dioxide on top and 2 moles of hydrochloric acid on bottom. And then our last step is our molar mass of carbon dioxide, 44.009 grams over 1 mole. Okay, so math, what are we doing? We've got 2.00 times 10 to the second. We're going to divide it by 36.461, divide by 2, and then multiply by 44.009. You get 120.70. Okay, so significant digits on here. This has 3, this has 5. Mole to mole ratios are exact. This has 5. We need our answer to go to 3. The 7 rounds the 0 up. So this is 121 grams of CO2. Okay, so you need to know what this means. This means this is the theoretical. Okay, so again, theoretical yield. All right, so then the next thing you have to understand is how to figure out your percent yield. So percent yield, straight from the formula chart, is actual yield over theoretical yield, and then you multiply by 100. You can find this on your formula chart. The green formula charts that I have, it's under other formulas. It's the third one down. So there's density, and then there's percent error, and then there's a percent yield. Okay, so actual, that, remember, we have to go back up to the problem. That's always what we're given in the problem. So we're given 1.00 times 10 to the second gram. Okay, so if we plug our numbers in, our actual, remember, is 1.00 times 10 to the second, and our theoretical was what we just calculated. That's 121. Now, when you put this in the calculator, you need to make sure you do this right. You need to make sure that you put the 100, oops, forgot to multiply by 100, times 100. Okay, now when you put this in the calculator, make sure that you put this 1.00 times 10 to the second in parentheses. So you do the 1.00 times 10 raised to the roof in parentheses, and then divide by 121, or know that 1.00 times 10 to the second is 100, 10 to the second is 100, times 1 is just itself. Whatever you want to do, I don't care, just make sure you do it right. Alright, so when you do this on the calculator, if you do it correctly, you should get 82.6446, blah, 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 keeps going. And then we need to do our significant digits. This has 3, this has 3, our answer needs to have 3, so the final answer is 82.6%.